I will refer to myself as Vincent Norman, the posh version of my name. I never call myself that, I'm always Vin. Okay, I'll say I am a junior, so we'll include the word junior. Now remember, at the moment our spinner doesn't work, there's no values inside it. Okay. Now immediate start, I'll leave this as false for now, we'll give a specific date. We'll say we can start from the 14th of December 2020. So we filled out our form. Let's see what happens now when we click preview message. Oh, it looks like our app has actually crashed. So what can we do? How can we find out what's going on? Let's open Logcat. I need to make sure I've got the correct emulator, so that one's disconnected. Let's go to the one that's running. Okay, and make sure we've got the app. Good, so we're inside our app now. I'm actually going to leave the whole form empty and just press the button because I actually do know what the problem is. To save some time, click preview message. Okay, and that's crashed. We get the pop-up saying it keeps stopping because it's crashed twice. Now, if I scroll up in my Logcat, null pointer exception. They've tried to call toString on a null object. And what's the line? Let's click it. In onPreview clicked, it's our spinner line. So we've tried to call toString on this selected item, but the selected item is actually null. Okay, now because this selected item property, this value comes from Java code, if I just control click it, command click it, this is some Java code. Okay, it doesn't declare that the thing it returns could be null, it just says object, which is like anything. Yeah, so unfortunately our Kotlin code doesn't know this could be null, otherwise it would be throwing up a warning saying we have to fix this. But not to worry, we now know that this is throwing up a null pointer exception. Okay, we know this selected item can be null, and we know from our Kotlin Foundations tutorial there's a way we can handle this. So can you think what the safe way would be to deal with this toString method? Because you can't call toString on a null Java object. So what's the answer? The answer is to put a question mark after the selected item. So just with one character, we've made this code safe. Even though we don't have anything inside our job title spinner yet, by using a safe call, by using a question mark to say, if it's null, then make the whole line be null, then we've solved the problem. So if I run the app again, and just open my... Okay, we've got a new Logcat. I click the button, and we don't get a crash. Okay, and if I fill out the form again, nice and quickly, Stephen Salesmith, Vincent Norman, we'll include junior, and we'll start on the 14th of December 2020. Now if I click preview message, I get the total with all of my values, and true and false. You can see for the immediate start include junior, so we can use Boolean variables in our string template, and even though we have a null job title, it just returns the word null. Okay, so that is the fantastic string templates, the super useful Kotlin string templates, which makes building up strings with multiple variables much, much, much easier. And as an added bonus, we got a chance to apply our learning with using the Android Logcat. It's time for another Kotlin Foundations tutorial, this time on functions. I'm in a brand new Scratch file in the Kotlin Foundations folder called functions. Okay, so I right click and then rename file, and I've called it functions. So if you can go ahead and do the same, I'm going to close my project pane, and that's there's no difference, two things that are slightly different. We'll do a pair of empty brackets, so no parameters, and then our curly braces. So just there we've made a new function in Kotlin, and you can see on the right that the log confirms that we have a make noise function available to us. Ignore the word unit for now. And in this, we will actually do a system.out.println. Now we could do it the old-fashioned way. We could do this. If you look at that suggestion, it says that we can actually use a println function. So one of the many, many useful shortcuts that Kotlin gives us, another one is a shortcut to that println function. So just println, all lowercase, println, and we can put inside here arg, exclamation mark, exclamation mark. If you look to the right, you can see we don't get any output there because we haven't called this function yet. So what we'll do, below this function, outside those brackets, we will now call this function. Make noise in the brackets, and if we wait a moment, we get the output, arg. Okay? So for a basic function or method with no parameters and no return type, it's pretty straightforward. Fun for function, and then the name of the function, and then our brackets like normal. So let's put a comment above this, so a new line, // and let's say, functions start with the word, single quote, fun, comma, then the name of the function. Notice how we don't have to specify a return type. In our Java methods, we have to do void and the name of the method, and void will say there's no return type. Well, in Kotlin, with functions, if the function doesn't return anything specific, we don't have to put anything. So that's nice and easy. So what if our function has a parameter? So let's make a new function, and we'll call this one greet, and then we'll pass into this function the name, so we'll greet a person. So similar to the way we do variables in Kotlin, rather than the type first, like it would be in Java, we do the name of the parameter first. So we'll say the word name, and then a colon, and then the type. So if you can think of the parameters in a function, just like when we did our variables, okay, so the type comes after the variable name, colon, type. So it has the same structure. And we'll do another print line, so all lowercase println, autocomplete, and inside here we'll do hello, space, and we'll add the name. And if you think back to a previous tutorial, we have a suggestion, and that's saying we can convert the mark after variable / like a variable, just to remind ourselves. And then just like in Java, we separate our parameters with a comma. And then we'll do a second parameter called age, and then we'll make that of type int, and we'll do our brackets. And we'll do print line again, so println. Okay, so that's absolutely fine. Let's test out our function now. Birthday cake, we'll do somebody else, Jenny, and we'll say she's 25. And if we look to the right, happy birthday, Jenny, now blow out your 25 candles. So that works just fine. So we'll do one more comment for the function with multiple parameters. So we'll say multiple parameters, we'll do number 1 of type int, and then number 2 of type int. And for now, we'll just do curly brackets, but we'll change this in a moment when we need to return something. So let's do the curly bracket. I'm just going to scroll down a bit. So we could do in this function something useful where we just multiply the numbers together. So number 1 times number 2. But right now, that's not doing anything. We could do a print line where we print that, but this function might be more useful to just return that value, like in our BMI calculator way back in the previous section, where we just return the value. So then we can let the place where it's called handle that value. It can do what it wants with it. So the way you return value is with the word return again. So we'll type return with a lowercase and then a space, and then we have an error. And that error is because we've not actually specified in the function that we are returning something. So if I hover over the error, it says type mismatch requires a get the required unit thing. And you see that? After the parameter, and that will now work absolutely fine. So let's now use this. Let's assign marks, and then we'll do 5 multiplied by 3 is, and then we'll do the $sign and result. And if we look to the right, 5 multiplied by 3 is 15. We know that works. So here we have a function that returns something. So let's put a note and say that thing there. Okay, unit, but found int. So a slightly odd sounding thing with Kotlin functions that you don't need to worry too much about. If I just scroll up to my very, very top function, we've got a function called make noise, and you can see that it says it returns a type unit, as does greet, as does birthday cake. So it's a feature of Kotlin that all functions return something, but if actually you don't want them to return anything specific, it returns this very basic type of object called a unit. You can think of this like the word void in Java. Okay, so we said private void and the method name. Void means it doesn't really return anything. But in Kotlin, every function returns something, but if you don't specify anything, it returns this weird unit object. And that's basically like void. Not quite exactly the same, but it's just like an empty, pointless, basic object which you do nothing with. In fact, on this make noise thing, I could say we return this unit thing, but this is redundant. We don't type this by default, so I'll just remove that. I could put return unit there. Okay, but that's also pointless. It does this automatically. So for a basic function that returns nothing, we don't specify a return type. Under the hood, it's returning this weird unit thing, but that's not anything we need to worry about. That's not anything you're ever really going to use. So you could think of it like the word void, okay? So right now, again, don't worry too much about this unit thing. In practice, you're probably never going to use it. You just need to know that if you don't want to return anything like my birthday cake method, then don't specify a return type. And then we don't have to word return anyway. We can just do some generic utility stuff like this. Okay? So that is a standard function with no parameters, a function with one parameter, a function with 2 parameters, and then a function that returns something, okay? Now, Kotlin goes one step further than this with some extra cool things. Sometimes, like in our multiply function, you might just have a one-liner. It might be a one-line function that just returns one thing. Well, if you have a one-line function, there's 3 different ways you can do it, each slightly nicer than the last. So let's make a new comment, and let's do 3 stars to make a new section, and we'll say there are 3 ways to do a one-liner function, which returns something. You'll see what this means in just a second. So, first of all, apologies for a bit of duplication here. There's the regular way, which is with curly braces, these things, your normal function or method body, and then the word return, and then specifying the return type. So just for a recap, we'll do a function, we'll call it square, to square a number, we'll give it one parameter called number, we'll make it type int, and we'll make it return an int. So we're going to literally square this number, we're going to multiply it by itself, and then return that int value. And we'll do some curly brackets. So we can now do number times number. Of course, we're getting an error because we actually need to return this. It's expecting an int to be returned because of this. So let's do the word return. So we have a regular function which returns a value with our curly braces. Well, if it's just a one-liner, you can do what's called a function expression. And a function expression doesn't use these curly brackets, it uses an equals. Let me show you this. Let's do a function, let's call this one square 2. So just our second way of doing a square function. Again, we'll give it a number parameter of type int. We'll do colon int, we'll specify the return type, but this time, rather than a curly bracket like that, we'll do an equals. And now we can just do number times number. How good is that? We don't even need the word return. This almost looks like we're assigning a variable, doesn't it? We have the name of something and the type of that something. In fact, if you got rid of this, and then change that to val, that would be a pretty good way of doing a variable. So this is a function expression, where you declare a function with all without parameters, specify the return type, and then just do equals, and then a one-liner. So let's put a note there. We can do a one-line function as a one-liner. And I'll put in brackets a function expression, okay? With no curly braces, and instead using an equals sign after specifying the type. Apologies for the long line there, okay? So rather than the curly brackets, rather than a function body, we just do an equals after we specify the return type. And then we can put our one-liner there. And doing a one-liner function expression like this. So expression and inferring the return type. So this means there's no need to specify the return type. This is a bit like our Kotlin variables. So this time I'll do fun, square 3, I'll do our number parameter again int. And this is where I would normally do colon int to specify the return type, but this time I'm not going to do that. I'm just going to do an equals and number times number. And that's it. And just like in our variables, Kotlin knows that when you times an int by an int, the result is going to be an int. Kotlin knows this, so we don't need to specify the type. So how quick and easy is this compared to our previous full block body like that? And just to show you that all these work as expected, I'll do square the first one and I'll do 5. Oops, you can see 25 there. Now I'll change this to square 2 and leave number 5 there. And scroll down again, 25, and then square 3, and scroll down again, and we have the same number 25. So, function expressions, simply meaning a function where you use the equal sign to immediately return a value. That's a function expression where you use an equal sign. These are a really quick and easy way to return values if you have a very simple function. If you need to do it on multiple lines, you need to do it the regular way with the curly braces. So hopefully you've enjoyed some of the nice things that Kotlin does with functions or methods. Personally, I do find them pretty fun to use, and that's not just because they start with the word fun, but they've simplified all of the things in Java that were a little bit long-winded and difficult to type. They made it quick and easy. So now you're able to make functions yourself. That is functions or methods in Kotlin. It's time for another programming concept, this time on access level modifiers. I've closed down all existing files. To teach this concept, we're going to work it through in a Java Scratch file. So if you can right-click on the Scratches folder, not the Kotlin Foundations folder, but the one above it, right-click, New Scratch File, and make sure you select Java, either from the top or if you have to scroll down. So Java, I'm going to do my usual thing and put the main method in a bit of space, just like that. And let's go ahead and rename this file now. So right-click on Scratch.java, and we'll do refactor, rename file, and we'll call this access space level project pane, so I've got full width. So when we talk about access level modifiers, we're talking about these words public, private, protected that you might have seen, or we don't specify an access. Let's make a new class, curly braces. So when we say access, we mean which other classes, which other files can access our fields, which other classes can access our methods. And there's actually only 4 levels. So we'll put a comment at the top of this class, so // and we'll say there are 4 levels of access in Java. We'll do a colon, public, protected, default, and private. So there's only 4 levels. we'll do another comment underneath and say these are shown below from most visible to most restricted. So let's do 4 string fields right now. So first of all, the most visible is public. So public string, remember in Java we put the variable type first, public string, and we'll call this one a public field. The next most visible is protected, so the word protected, and then a string again, and we'll call this a protected field. Then the next level in Java is what's called the default access, and this is the level of access where you don't specify anything. So we'll just say a string here. So we're not giving this any specific access, so it's a default access field. And then finally, the most restricted is the private. So private string and a private field. So to illustrate the level of access that these 4 fields have, we'll assign them to a string value which describes that. So starting with public, we'll make that equal to a new string, and we'll say this can be accessed from any class. Simple as that. If you declare a field or a method public, any file, any class in any folder in any package can use that method, can use that field. Okay? So that's the most visible, the least restricted. Next is protected. So with the protected field, we'll do equals. This can be accessed from either, and there's 2 scenarios for which files can access this. A class in the same package, you can think of that as the same folder, but specifically it's the same package, and I'll show you what I mean by this in just a moment, or a subclass, and by that we mean child class. Okay? So to show you what I mean by the same package, I'm going to jump over now to our project pane and our app folder. So open the project pane. If I just go into our project and I'll go down into app, the source folder, main, Java, all the way to our main activity. Our main activity is in the com.vinnormal.self-promo app package. If I just quickly open the file, you can see at the top, there's the package. Okay? And pretty much always, this should match the folders as you see them here. So you can think of them as folders, same folder, same package. Okay? If I make another class in this same package, or same folder, then this will be able to access main activity's protected fields. But if I right click and make a new package like this, a new package, don't do this, just this is for illustration only. If I make a class in this new package, which is a different package, this will not be able to access the protected fields in main activity, and main activity will not be able to access the protected fields of classes in this package. Okay? So when we say same package, we mean sort of like the same folder. So with the protected field, it can be accessed from either a class in the same package or a subclass. So if I go back to these packages here, if I made a class in the new package, extended from main activity, access those protected, confusing, or you're struggling to remember this or know exactly what I mean, what I will say is you don't really need to worry too much about the protected field, and indeed the default field, which I'm going to mention in a moment. The most common ones are public and private. Okay? But good to know, protected field is the second most visible. It can be accessed from any class in the same package, or a child class, a subclass, which again can be in any folder if it's a subclass. And this leads nicely onto our default access. If we don't specify anything, then this can be accessed from a class in the same package only. So default access and protected access are very similar, but default's a bit more restricted. It's only from classes in the same package. If it's a subclass or a child class and it's in a different package, then it wouldn't be able to access them with the default level. Okay? And then finally we have our private access. This can only be accessed from within this class. So private does exactly what it says really. It means it is only accessible from within that class. So public. Okay? And what we'll do is we'll do a quick system.out.println in each of these so we can show where we are. So I'll do system.out.println in the public method. And I'll copy the whole line to both these places. And then this is in the protected method and in the private method. Okay? So we have our 4 fields and we have our 3 methods. First of all, I'll show you what we can and can't access. So if we scroll to the top now to our Scratch file, we'll make a new access level modifiers object. So in Java, the variable type comes first. So access level modifiers, our level tester we'll call it, and that equals a new access level modifiers class, semicolon. So first of all, we'll try and use the private field, level tester dot a private field. You'll see that autocomplete doesn't even work for this. If I do a semicolon, it won't say that this isn't found. It will actually tell us that a private field has private access. So it knows that field exists, but we can't use it. That is an error. This will not run. Okay, so let's comment this line out, and we'll do an arrow, and we'll say won't work. This is a private field. Next, we have our private method. Let's do level tester dot a private method. Okay, slightly different error highlighting, this time they've underlined it. Won't work. This is a private method. That can go the public and like they're in the same package. So actually protected and default, they would both work in our Scratch files. So let's just prove this now, and we'll do our level tester, and we'll do a public method. And we'll just go ahead and run this, and we have in the public method from there, okay? So we can't directly access a private field or private method, we can access them indirectly. So to show you what I mean, I'm going to change my public method to actually return a string. So that's expecting a string to be returned, and under our system.out, now we can return a private field. I can use autocomplete. So just because we declare some fields or some methods private, like a private field, it doesn't mean that we can't give them out to the world, to other classes some other way. Just not done. This can be a local variable, we're only using it once, so you can ignore that warning. We're getting another private field from our... So if we do system.out.println now, we can say, got the private field from a public method. The field is, and we can add that returned private field. So if we run this now, no error, everything works, we're in the public method, and then we log, got the private field, the field is, this can only be accessed from within the class. And likewise, with our private method, even though we can't directly access it, we can call it from other more visible methods. So if I go to our protected method, which our Scratch file can access because it's in the same package, and I, in this method, call a private method, well, now, in our level tester, I can do level tester dot a protected method, and when I run this, we get in the protected method and in the private method. So you see, we can declare some things private in our classes, a private field and a private method, but that doesn't mean that the outside world, the outside classes will never see them or never use them. It just means they can't directly access them. And it's very common to restrict the inner workings of our class, some things that we don't want other people to directly call, but then expose it through something else that's slightly more public, just like this. Okay? So we'll put a comment above this protected method, and we'll just say, / the below protected method is okay to call, as in these Scratch files. It is as if we're in the same package. Do another line. This method then calls its internal private method, and so we can see the output. So that is the basics of access level modifiers. On the surface, quite simple, just different levels of visibility for our fields and methods from outside the class where we write them. And for the time being, you can not really worry too much about protected or default. It is public and private that is going to be most useful to us. So that is the concept of access level modifiers. We've covered that here. But to really solidify our understanding of why it's important and why we would bother with this, and why we wouldn't just make everything public, I'll show an example that will illustrate why it's really important to not just expose everything publicly, and to really think about what things we want to be available from outside the class, and what things we want to be private and be contained inside the class. So we'll do that next.